Hi everyone, good day. I am Zanjo Kimpi Partosa, a third year student taking up Bachelor of Secondary Education major in English together with Mr. Gerald Pakshal, who is also taking up Bachelor of Secondary Education major in Mathematics, and we are studying at the same college, which is Negros Oriental State University, Shatin Campus. We were assigned to discuss the topic measures of dispersion or variability. I am assigned to define the terms, which are the variance, the range, and the standard deviation, and Mr. Gerald Pakshal is assigned to give us the examples. Please continue watching for you to learn something.
In relation to measurement, we have here a quote by Lord Kevin. He says, if you cannot measure it, then you cannot improve it.
So let me welcome you to our discussion about the measures of dispersion or variability. For our learning outcomes, by the end of this discussion, the learners will be able to define the different kinds of measurements of dispersion or variability, compute and explain the range, standard deviation, and the variance. And then we have apply the correct measure or measures of dispersion to any given variable based on that variable's level of measurement. So the measures of central tendency are not sufficient to describe data. Two sets of data can have the same mean, but they can be entirely different. Thus, to describe data, one needs to know the degree of variability. Variability is the extent to which a numerical data is likely to vary about an average value. It helps us to understand how scattered the data is in the distribution. Dispersion refers to the distribution of objects over a large region. The degree to which numerical data are dispersed or squished around an average value is referred to as dispersion in statistics. So the measure of dispersion is always a non-negative real number that starts at 0 when all the data is the same and rises as the data gets more varied. The homogeneity or heterogeneity of the scattered data is defined by dispersion measures. It also refers to how data differs from one another. So now let us tackle the characteristics of measures of dispersion. So first characteristic is that a measure of dispersion should be rigidly defined. Second is that it must be easy to calculate and understand. It must not be affected much by the fluctuations of observation, and it should be based on all observation. So apart from the characteristics of measures of dispersion, we also have the classification of measures of dispersion. The measure of dispersion is categorized as first, an absolute measure of dispersion. So here, the measures express the scattering of observation in terms of distances, like for example, the range, the quartile deviation. So the measure expresses the variation in terms of the average of deviations of observations like mean deviation and standard deviation. Second category or classification of measure of dispersion is that it is a relative measure of dispersion. So in here, we use a relative measure of dispersion for comparing distributions of two or more data set and for unit-free comparison. They are the coefficient of range and that the coefficient of mean deviation, the coefficient of quartile deviation, the coefficient of variation, and lastly, the coefficient of standard deviation. So now we will tackle about the range. So range is the simplest measure of variability. It is simply the difference between the highest and lowest score. So the main advantage of this measure of dispersion is that it is easy to calculate. On the other hand, it has a lot of disadvantages. It is very sensitive to extreme scores and does not use all of the observation in a data set. it is more informative to provide the minimum and maximum scores rather than providing the range. So range refers to the difference between each series minimum and maximum values as what I have stated a while ago. The range offers us a good indication of how dispersed the data is, but we need other measures of variability to discover the dispersion of data from central tendency measurements. A range is again the most common and easily understandable measure of dispersion. It is the difference between two extreme observations of the data set. So if x sub maximum and x sub minimum are the two extreme observations, then we have the formula range equals x sub maximum minus x sub minimum. So, to continue, let us discuss the merits of range. So, for the merits of range, we have first, it is the simplest measure of dispersion. Second is that it is easy to calculate. Third, it is easy to understand. And lastly, it is independent of change or region. So, if we have the merits of range, we also have the demerits of range. First is that it is based on two extreme observations. Hence, it gets affected by the fluctuations. A range also is not a reliable measure of dispersion. And lastly, it is dependent on change of scale. Then we will move forward to the variance. So the variance is a measure of variability. Variance is defined as the average square difference of the scores from the mean. It tells us how close the scores are from the mean of the distribution. Variance tells you the degree of spread in your data set. The more spread the data, the larger the variance is in relation to the mean. Variance is expressed in much larger units, for example, meters squared. So since the unit of variance are much larger than those of a typical value of a dataset, it is harder to interpret the variance number intuitively. That is why standard deviation is often preferred as a main measure of variability. However, the variance is more informative about the variability than the standard deviation, and it is used in making statistical inferences. So in calculating the variance of data points, we square the difference between each point and the mean because if we sum the difference directly, the result would always be zero. So for example, suppose three friends work on campus and earn $5.50, $7.50, and $8 per hour respectively. So the mean of these values is quantity $5.50 plus $7.50 plus $8 divided by or all over 3 equals $7 per hour. So if we sum the differences of the mean from each wage, we would get quantity 5.50 minus 7 plus $7.50 minus 7 plus $8 minus 7 equals negative $1.50 plus 0.50 plus 1, which is equal to 0. So instead, we square the terms to obtain a variance equal to 2.25, which is the square of negative 1.50 plus 0.25, which is the square of 0.50, and plus 1, which is the square of 1 itself. So we have a total of 3.50. Okay, so population variance. Now, when you have collected data from every member of the population that you are interested in, you can get an exact value for population variance. Now, for the population variance formula, it looks like this. Population variance is equal to the summation of quantity x minus mean squared over capital letter N because capital letter N symbolizes the population. Meanwhile, sample variance is that when you collect data from a sample, the sample variance is used to make estimates or inferences about the population variance. So for its formula, the sample variance formula looks like this. Sample variance is equal to the summation of x minus mean squared over n minus 1, wherein the n here is in lowercase. So with samples, we use n minus 1 in the formula because using lowercase n would give us a biased estimate that consistently underestimates variability. The sample variance would tend to be lower than the real variance of the population. Reducing the sample n to n minus 1 makes the variance artificially large, giving you an unbiased estimate of the variability. It is important to note that it is better to overestimate rather than to underestimate variability in samples. It is also important to note that doing the same thing with the standard deviation formulas doesn't lead to completely unbiased statements estimates. Since a square root isn't a linear operation like addition or subtraction, the unbiasedness of the sample variance formula doesn't carry over the sample standard deviation formula. So now, let us proceed to the steps for calculating the variance. So the variance is usually calculated automatically by whichever software you use for your statistical analysis. But you can also calculate it hand by hand to better understand how the formula works. So there are mainly five main steps for finding the variance by hand. First is that we should find the mean. Now, to find the mean, you should add all up the scores, then divide them by the number of the scores. Then, we have the step 2, which we are to find each score's deviation from the mean. Now, to fulfill this step, we need to subtract the mean from each score to get the deviations from the mean. So, after this, then we will proceed to the step 3, which is to square each deviation from the mean. So, multiply each deviation from the mean by itself, as this will result in positive numbers. Then, moving forward, we will proceed to step 4, which is to find the sum of squares. Now, to find the sum of squares, add all up the squared deviations, as this is called the sum of the squares. Then lastly, or the step 5, the last step is we should divide the sum of the squares by n minus 1 or capital letter N. Now, to fulfill or to achieve this, we should divide the sum of the squares by n minus 1, considering that it is for the sample, or capital letter N for the population. Okay, so moving forward, we will now tackle about the standard deviation. So standard deviation also tells us how close the scores are from the mean of the distribution. It is simply the positive square root of the variance, and a standard deviation, again, is the positive square root of the arithmetic mean of the squares of the deviation of the given values from their arithmetic mean. So it is denoted by a Greek letter sigma or the sign, and it is also referred again to us as the root mean square deviation. So the standard deviation is the average amount of variability in your data set. Again, it tells you on average how far each value lies from the mean. A high standard deviation means that values are generally far from the mean, while a low standard deviation indicates that values are clustered close to the mean. Standard deviation formulas for population and samples. Different formulas are used for calculating standard deviation depending on whether you have collected data from a whole population or sample. Now, let us tackle about the population standard deviation. So when you have collected data from every member of the population that you are interested in, you can get an exact value of the population standard deviation. Now, the population standard deviation formula looks like this. Population standard deviation is equal to the square root of summation quantity x minus mean squared over n, which the n here again is capital letter because it represents the population. For the sample standard deviation, when you collect the data from the sample standard deviation is used to make estimates or inferences about the population standard deviation. Now the sample standard deviation formula looks like this. Sample standard deviation is equal to the square root of the summation of quantity x minus mean squared over n minus 1, as n minus 1 determines that it is the formula used for the sample. So with samples, we use n minus 1 again in the formula because using n would give us a biased estimate that consistently underestimates variability. The sample standard deviation would tend to be lower than real standard deviation of the population. Reducing the sample n to n minus 1, just like what we mentioned to the variance a while ago, makes the standard deviation artificially large, giving you a conservative estimate of a variability. While this is not an unbiased estimate, it is less biased estimate of standard deviation. It is important to note that it is better to overestimate rather than underestimate variability in samples. To proceed, we have the steps for calculating the standard deviation. So the standard deviation is usually calculated automatically by whichever software you use for the statistical analysis. But you can also calculate it by hand to better understand how the formula works. This is the same with the variance again a while ago. So, for the standard deviation, there are 6 main steps for finding the standard deviation by hand. Step 1 is find the mean. Now to find the mean, add up all the scores, then divide them by the number of scores. Second step, find each score's deviation from the mean, and then to achieve this is that we need to subtract the mean from each score to get the deviations from the mean. Step 3, square each deviation from the mean. Now here, we need to multiply each deviation from the mean by itself. So this will result in positive numbers. For the step 4, we need to find the sum of squares. Now to find the sum of squares, we need to add up all the square division. Step 5, we need to find the variance, as variance was discussed a while ago. So to find the variance, we need to divide the sum of the squares by n minus 1. This is for the sample, or capital letter N for the population, because this is how we will calculate the variance. For the step 6, we need to find the square root of the variance. Now to find the standard deviation, we take the square root of the variance. So to proceed, we will tackle now the merits of standard deviation. So for the merits of standard deviation, it is squaring the deviations overcomes the drawback of ignoring signs in mean deviation. We also have, it is suitable for further mathematical treatment. Then we have least affected by the fluctuation of the observations, and then the standard deviation is 0 if all the observations are constant, and then lastly, it is independent of change of origin. So while we have the merits of standard deviation, we also have the demerits of standard deviation. For the demerits, we have it is not easy to calculate. It is difficult to understand for a layman, and lastly, it is dependent on the change of scale. Now, to provide you the examples of range, variance, and standard deviation, Mr. Gerald Pakshaw will further explain the examples for us to grasp the real essence of the discussion. So that's it, guys, for our discussion. Hope you learned something from our discussion about measures of dispersion or variability.